Hi kids, now we'll be discussing about this question from your study material. Negligible relaxed length of that string. Anyway, so negligible relaxed length, they can frame like various questions because it is linear relation. It will turn out to be much easy question. So this is the question from the package. Anyway, you can pause and you can read the question. Okay, thread is the negligible relaxed length. So natural length is almost 0. It is stretched between the 2 points A and B like this. In this state, the thread makes an angle theta with the horizontal and its length and force constant are L and K respectively. Length is L and spring constant is K kind of. A spider of mass M crawls gradually from end A to B on this thread representing horizontal by x-axis and vertical by y-axis. The point A is origin. Find the equation of the path followed by the spider assuming the thread obeys Hooke's law. So K into X will be the force kind of thing. So when the spider is at this point where this length is L1 and this length is L2, this length is L1, this length is L2 and this spring constant is K1 and this spring constant is K2. So when the thing is at this point, so due to weight it will be going down and it will be balanced at some certain point, then there will be this elastic force from this side and this side. So this elastic force will be given by K1 into this length, because that's natural length is 0, right? So force is going to be K1 into this length. Its horizontal component is going to be K1 into this length. That you can manage by yourself. So if the x coordinate, see, I have taken x coordinate as x and y coordinate is y. X coordinate is positive, y coordinate is negative. So I can put as modulus x and minus modulus y. Right? So this distance is modulus y, I can write it as minus y. This distance is modulus x, I can write it as x itself. This total distance is L cos theta. So this distance is L cos theta minus mod x, which is L cos theta minus x. Now this total distance is L sin theta and this is mod y. So L sin theta plus mod y. But what is mod y? Mod y is minus y. So those distances you can manage. Now this force is going to be K into this length. Now its horizontal component is going to be K into this length component, which will turn out to be K1 into this length. So similarly, this force is going to be K1 into this length, K1 into this length. So these things. Now this is happening because these are the good things happening. These are happening just because the natural length is 0. Natural length is 0. So that's the key point. If natural length is 0, calculations are turning out to be pretty simple. Now similarly, this stretching force, you can resolve into two components. Its horizontal component will be given by K2 times of this distance. Its vertical component will be given by K2 times of this distance. And weight will be there. There is weight. So those are the forces. This horizontal component and vertical component, this horizontal component and vertical component and weight. So net horizontal force is 0, net vertical force is 0. So when you write that, you will be getting these two equations. Net horizontal force is 0, net vertical force is 0. So when you modify it, you will be getting these two equations. Now from these two equations you can find what is K1 and K2. From those two equations you can find what is K1 and K2. Those are the two equations. I just multiplied with y on both sides and I did some calculation and I will be getting K2 value. After I get K2 value, I can substitute it back and I can get what is K1 value. Now anyway, how does this going to give us the equation? So we found K1 and K2 in terms of x and y. So basically if we can get one relation between K1 and K2, then that's sufficient enough. Now that relation we will be getting from the initial situation. Now if I talk about this point, that point is being pulled with K1 L1 and K2 L2. So basically I can say K1 L1 equals to K2 L2. Now which is same as the total, if I take this total thing together, then the force is K into L, right? Because they said spring constant is K and length is L, natural length is 0, so extension is L. The other way, and length is L1 plus L2 is total length. Now I can assume this is some constant. So L1 is some constant by K1, L2 is some constant by K2, L is some constant by K. When I substitute it, I will be getting 1 by K1 plus 1 by K2 equals to 1 by K. You can argue that anyway these two are in series, so 1 by K1 plus 1 by K2 equals to 1 by K. So basically once I get this relation, I got K1 as a function of x and y, K2 as a function of x and y. So I can substitute them back to get the answer. I got K1 as a function of x and y, K2 as a function of x and y. This I can substitute in this equation. K1 and K2 I just substituted, and it's only about modification. You will end up with the answer, right?